Okay, so today my presentation discussion is on IPv6 because IPv6 is the new protocol, as all of you know, which is taking us off from the scarcity of IPv4. As network managers, network engineers, and people working for internet network technologies, you already know that we don't get new IPv4 addresses. Punic is there. You go and ask him for some IPs. You'll say, go home, right? What do you say? Ubudu, you will give new addresses? Only a bare minimal that you will give. If you are starting a new network, you will not get new IPv6 addresses as much as you like. Say they will give you only a bare minimal allocation, which is obviously not enough for you to start a new network. So that is the situation. That is why IPv6 comes as a solution, as the solution, in fact, right? So now in this, as Champika said, I'm going to talk about some of my experiences in the industry as a service provider, as well as why, when, and how you should implement IPv6 in your networks. I'm sure that there are, I saw in the list of participants, there are a lot of service providers representing here, and also other organizations. Can I have a raise of hands who has IPv6 in their networks? Yeah, I can see many. So ICANN, University of Moratuwa Learn, all the universities are raising their hands. So the government is doing well, right? So the state sector is doing well. ISP as SLT is yes. Dialog is there, yes. A lot of other operators, yes. Any private companies who are having IPv6? Or companies who are having banks, maybe, or other institutions? None. Okay. So let's go ahead and see why we need IPv6. As I said earlier, IPv4 has already run out. You don't get any more allocations, new allocations. You get only a minimal allocation from Punic now if you ask for it. And it is a new addressing scheme. It is 128 bits long. I don't need to tell you this. All of you should know by now. And it is so big that we all can have a real IP. Now if you look into your network, you will get only a private address, which is netted at your home and again at your ISP and maybe another in another place. It's netted always, and it's not optimal routing. So with IPv6, that whole thing goes away. If you still want to net, you can net, but it is not recommended. You get a real IP end to end. That is the idea of IPv6, right? That is why we have 128 bits. And if I'm proud to actually tell you now, we have SLT ADSL and SLT LTE set up here, which is on dual stack. It is on IPv6, IPv4, whatever protocol your device is supporting now is carrying IPv4 as well as IPv6. So you open your Wi-Fi, you will see one ADSL, one LTE. They are all on dual stack now. So the password is SLT LKNOG. You try it out on your PCs if they are IPv6 enabled. You are now on IPv6. So it is real. It is there. It is now. It is not in the future, right? So that is the message I need to put into you. And don't expect during this session, I'm not going to technical details of like how to type like subnetters, IPv6 prefix, or how to build a network in technical details, but I'm going in very high level how you should approach, you should approach the deployment of IPv6 in your networks. So it's not anymore a minority. The traffic is going very rapidly. As soon as you put your network on IPv6, it will carry almost 80 to 90% of your traffic on IPv6 as soon as you put it on. Those who have put it on have seen it. Learn, I asked this morning, I asked from Tilina. Learn is carrying around, if it is IPv6 enabled, carrying around more than 50% of traffic on IPv6. Am I right? Yeah, more than 50% of traffic on IPv6, Learn. So that is the state universities. And there are IPv6 only operators emerging in the market. I'll come to examples. And there are IPv6 only apps growing in the market. For example, starting from June 2016, all apps submitted to Apple App Store must be certified for IPv6 only networking. It doesn't mean that it doesn't support IPv4, because if you are on IPv6 only environment, this Apple Store apps should work for it. So they are now ready. They are getting ready. So it is real. And Microsoft internally in their network, in their corporate network, they are going for IPv6 only. And T-Mobile US has already launched IPv6 only service provisioning. So anything IPv4 is carried over IPv6 network in T-Mobile US. So IPv4 has already become a minority in US. So that is, so the requirement is real and now. And if you look at the global status of IPv6, world is now at around 15%. The global penetration is about 15% of the machines that connect to the internet are IPv6 capable. And in Asia, we are also at a certain level, 15%, 14%. And Sri Lanka is a little bit lagging. But India, you take an example, you look at this URL here. India is more than 50%. Yeah, because of one particular operator, I think Reliance Jio is doing that because their whole network is on IPv6. So South Asia is very high because of India, because India is more than 50% on IPv6. And if you look at the Google statistics, it is again proving it. The total traffic coming to Google right now is carrying around 17% IPv6 traffic, right? It is growing. So you see the chart, it is growing. You can type this URL and see it is growing. And in Sri Lanka, there are 6 parties joining in the game, right? These are the 6. Sri Lanka Telecom, this is based on the ranking on the internet, and this is not my data, it is what? It is data from the internet. And Dialog is there, Learn is there, Lankacom is there. I wonder if Lankacom is providing services, end-user services for IPv6? Yes. Yeah, similarly, the other providers are also. And Mobitel is there. They are advertising their prefixes, but that doesn't really mean that they are providing a service to the end user. Mobitel, are we providing services to end users? Probably yes, they might be testing. And Etisalat is also there advertising their prefix into the internet. So if you go to the internet, there is a route, but it doesn't necessarily say that there are end users who are actually enjoying the service. Yeah, I'm representing a SLT, so I can proudly say we have customers. Our first customer was, in fact, Learn, and in 2007, that's so many years back. And now we have the real-life broadband enabled for IPv6. So about the end users, Windows is Windows 7, Windows 8, even Windows XP. All those OSs are by default supporting IPv6. And if you now, if a new laptop, Windows 7, Windows 8, Windows 10, if you put it on, it will prefer IPv6. Linux will also do the same. Android will also do the same. iOS will also do the same. If you have both stacks, it will prefer IPv6. That is why as soon as you put your network on a dual stack, 90% of the traffic will be in IPv6, because if you may, like, what do you use your internet mostly for? YouTube, Facebook, Google, Akamai, content providers, Limelight, those networks are all on IPv6. So as soon as you put your network on the dual stack network, 90% of your traffic will be on IPv6. So, and again, there was a repeated discussion about IoTs. So IoTs definitely cannot work with IPv4, can they, right? There's netting and so many different things, and you don't have enough IPs to support IoT. IoT definitely needs IPv6. That's the key driver for IPv6. So IPv6 no more in the innovators domain or no more in the early adoption domain. It is now at the early majority stage. It is becoming a majority. As I said, T-Mobile has done IPv4 on top of IPv6. So IPv6 is native, and IPv6 is carried, tunneled over to the internet. So earlier, 5 years back, it was the other way around. We had IPv4 and we had tunnels connecting IPv6 domains together. Now it is the other way around. So we are in the early majority stage. Keep that in mind. So why do you need the IPv6? Item number 2 is that if you start early, we started in 2006. If you start early, it's less costly and less effort. Because for a service provider like us, there's a lot of infrastructure, there are a lot of different domains that we need to pass to give service to the customers. All these domains need to be upgraded. It's a heavy task, it's a difficult task, and it's a very risky task. So if you start early, you can gradually enforce policy that IPv6 has to be there for your new investments. And train your people, bring them to a comfort zone so that they understand the technology and they are comfortable with working with both protocols. And you don't need to jump, like it's not like that you are migrating from IPv4 to IPv6. They are coexisting. They look like two different networks to you. IPv4 network is there. On top of it, on the same infrastructure, IPv6 network is there. So these two have to coexist. You are not migrating IPv4 to IPv6. You are actually adopting IPv6 into the existing network. And again, I'm repeating, so if you start early, you can enforce that all the new assets that you are buying into, your firewalls, your routers, your whatever the IP investment, IP networking and systems, you have to enforce a policy that whatever you buy has to support this protocol. So that is what we did. In 2007, we started enforcing policy on new investments. You have to dual stack. You have to do anything that we buy, we enforce. And now we are ready. If we did not do that at that time, we wouldn't be ready, because providing a simple ADSL service is a heck of a task for network managers, for ISP operators, for the access operators. So there are so many places where there are, complexities, the gateways, the BRASs, the ADSL router itself, and then the ISP, then the counting of usage, so many complexities. If you did not start that early, this wouldn't have become a reality today, because you are now enjoying IPv6 on LTE as well as ADSL. So the number 3 I need to highlight is avoiding IPv6 is costly. Why? You have to invest on workarounds. You don't have enough IPs. You have to invest on NAT, you have to invest on firewalls, and so maybe for service providers, CGNAT, and then so many carrier-grade netting, and so many other investments you need to do because you are not going on to IPv6. And you will lose confidence soon from customers because you are lagging technically, right? If you are a bank, every other bank, or if the global bank are supporting IPv6, soon the Apple phone will stop providing, maybe, don't know, IPv4 service. It will be native IPv6. Then your banking system cannot connect to your banking app. Do you like that to happen? No. So it is a bad reputation. If you don't start now, you will be technically lagging, and you will lose that cutting-edge technology brand, right? So don't lose that brand image. Do it now. So be ready now. And it's not just a task, it's a journey. You have to have time, and you have to do it gradually. And if you do not start now, it may be too late for you. Be with the cutting-edge technology and protect your reputation. No more IPv4. Punic is not giving you any more big chunks. If you are planning to deploy a new network, you will not get it. And it costs more when you are late, and it takes time to learn and come to the comfort zone, right? That is the basic message I would like to give you. And then how you should deploy. First thing, if you are a network that has not deployed IPv6 yet, go and ask your ISP. If you are a direct member of Punic, go and ask Punic, please give me IPv6. They will, without any hesitation, they will give you a for a corporate /48, meaning you can have so much IPs. You don't need to worry about subnetting and doing whatever stuff, playing with the IPs. They will straight away give you no questions asked. Earlier, IPv4, we had to we had to fill a form justifying why we need this many number of IPs. We have to write it so thoroughly, otherwise it get rejected. Champika will reject it, right? Now Champika is in ICANN, he is up in the ladder now. Still, now if you want to have an email in a small chunk, you have to write so much to get it, right? And so IPv6, it's not so. As soon as you ask, it will happily give you any number of IPs. For an ISP, you get a /32. /32 means how many? I don't know. So out of 128 bits, a 32 subnet will be given to you. 32 bits subnet will be given to you for an ISP. And you ask for connectivity from your ISP. We are happy to give you connectivity as soon as you request. Lankacom is there, Dialog is there, Mobitel is there. All the providers are now providing IPv6. So you can get your numbers, get your connectivity. Then you can start your journey. Number 2, start early, start now. If you have not already started, start now. And train people and develop people. We will help. LKNOG is a platform for you to get help. So we will support. We will have some workshops for that, hopefully in the near future. And then we will bring you to the comfort zone. And the next step is that you go into a network and identify the gaps. What are the systems that you have? What are the routers? What are the switches? What are the servers? What are the DNS servers that you have? Or what are the application servers that you have? And what gaps do they have if you want to enable dual stack? What are the gaps? Do an audit, simple audit. Once you come to the comfort zone, you know the technologies and simple things about IPv6. It's not a difficult task. Or you can get help from the networking community here. That is the idea of LKNOG. And then you need to identify strategy. Well, I would say IPv6 only, number 1 preferred, maybe, but it might not work when there are IPv4 customers also. So naturally, go for dual stack. And if you can't do that, then maybe tunnel, right? And then identify your priorities and build your strategy. How are you going to do it? Where are you going to start with? So don't do it at once. You don't need to do it as a, one-day migration. You can do it gradually. Enforce compliance to your new investments. Every firewall that you buy, every router that you buy, you specify that you need IPv6. These are the functions that I need. And implement step by step. Security is a very key thing, as Professor Dias also spoke about it earlier. You have to build in security into your things and think about it, because building IPv6 doesn't mean it has security. There's a bad, wrong conception that IPv6 is more secure. It's more secure when you implement security. It has facilities to implement security better than IPv4, but if you don't implement security properly on IPv6, it will be a worse case, because your IP is real and you are end-to-end connected. So you have to be very careful of security. But don't worry, there are mechanisms to do that. And your web presence, then next step would be your web presence. Maybe you can initially enable your website on dual stack. SLT.lk is on dual stack. Now if you have your trace routes, type it on our Wi-Fi, LTE or ADSL, you will trace on IPv6 to SLT.lk 2.2, right? So if you do an NS lookup now, it will show up priority is IPv6. And then you can move on to internal networks. First thing, the outside world sees your website as dual stack. So that's a good point, right? Your site is on dual stacks. I am proud to be IPv6 enabled. You can do the certification online, ipv6test.org or net. And then you can get the label, IPv6 enabled, ready. Label and plug it into your website. So that is technically what did I say? Not lagging, but cutting edge technology you can advertise in your site. Be careful of the security though, right? And then you can go into internal networks, and then maybe you can go into your backend systems. Because in maybe a foreseeable future, the IPv4 will be switched off. Not very likely, but one day it will be switched off, right? So you have to go step by step. Enforce security on dual stack, and make your web presence dual stack, and make your internal networks dual stack, or IPv6 only, preferably IPv6 only, and then backend systems, also on IPv6. So for a service provider, so this is the case study part that I'm going through now. As a service provider, the first thing I faced was, this was an effort of few individuals, enthusiasts like me, myself, and some of my engineers, some of my colleagues. It is a sole effort of those technical guys, not from the top. It's not coming from the top. IPv6 did not come from the top, right? It came from individuals like us, enthusiasts. But the business doesn't see any dollars of, as for a service provider, we don't get any additional revenue out of IPv6, do we? Any service operators, do we get any additional revenue? No, I don't think we get any additional revenue. Most of the end users don't care whether it is IPv6 or IPv4, as long as your Google works, as long as your Facebook works. They don't care whether it is IPv6. But it's our reputation. Service provider has to have a reputation that you are at the edge of technology. We are always in par with the technology. So we had to do it. And there's no, sadly, Professor Dias, there's no regulatory pressure in Sri Lanka right now for encouraging IPv6 adoption. That is a sad story, but I think it should be there. So we had some initiatives a few years back, but now it's almost non-existent. I wish we had more pressure from the regulators in the industry. And for Sri Lanka, being a smaller country, we don't have so much of an address crunch. We have sufficient addresses, and we have these netting mechanisms already in place. We can survive with IPv4 only. We don't need IPv6 just for the sake of lack of addresses for service providers, because we have big chunks. We do netting, but then when we go for service provision, there are issues. Now, when netting, CCTV cameras that you have, you cannot watch your the DVR, right? If you have a net, you cannot see. Then you can have to go and ask for your service provider, please give me a mapping, static mapping. Give me a real IP mapping. Don't net me. Otherwise, your CCTV DVR, you cannot go and watch your CCTV DVR. So these are the issues that the customers will face while we are doing IPv6, IPv4. And also, there's no serious demand pull. No, only a handful of customers will come and say, hey, I need IPv6. Professor Dias did. Professor Dr. Ratnayaka did in 2007. They came and asked us, can you learn IPv6? Yeah, within 2 days we gave, right? So that is that kind of demand is not there in the rest of the community. And the broadband customers, they don't care, except for some enthusiasts who want to, jiggle around and do some experimental stuff with IPv6. So there's no serious demand pull, but the world is, as you saw earlier, the world is moving its traffic onto IPv6. 17% now. Within 1 year, it will be more than 25%. There are some operators who are only IPv6. The iOSs, the Androids are going for IPv6 only apps. So the demand will come from end user devices itself, and some of the other operators who are only on IPv6. So there's no chicken and egg syndrome. It was there when we started. Now it is no more. Now it is, the chicken has actually come out of the egg, right? We are in the early majority stage now. So there's no more chicken and egg. No demand versus supply issue is not really there now. It is that thing is now, that equation has broken. For a service provider, in my case study, I'm not particularly speaking for SLT, but any service provider will face the same concerns. It's a long and difficult journey. Success depends on some individuals who are leading it, and you have to lead from the top. And you have to learn and aware the others. You share your knowledge and bring them to the comfort zone. And you have to lead and create a task force or a steering committee to do things that you will not do as your day-to-day business. And you have to get the blessings of the management, and then operationalize in stages, gradually. So the natural path for service providers is to go for dual stack, right? All of the service providers here, I think, who are supporting IPv6 are on dual stack. Because we have to support both V4 only customers and V6 only customers and dual stack customers. So first thing we did enable the ISP network and its services, supporting services. We upgraded the routers, ISP, DNS servers. Definitely you need DNS servers, otherwise your browsing will not be resolved. Your addresses will not be resolved to IPv4 addresses, V6 addresses. And upgrade your web services, www.slt.lk. You upgrade. It's not a difficult task. Configure your security infrastructure. That is very key. Your firewalls, your IPSs, your DDoS protection systems, your all the threat prevention mechanisms have to be thoroughly investigated and properly managed. All the same configurations that you have for IPv4, similarly, has to be put on to IPv6. But the next generation devices, they support object-wise control. Say you want to control something, you select object, not the IP, and then put the rule onto it. And it's becoming easier now. And you have to enable your NMSs. Once you put IPv6 on, if your NMSs, your monitoring systems do not support IPv6 monitoring, you cannot monitor your customers' performance service levels. You have to enable those. And you have to enable your operational support systems, OSS, to support IPv6 particular fields. Say if you are a static IP kind of customer, if you want to create a static IPv6 address, you have to support it on your provisioning systems. And then to carry the traffic, you need to enable your internet lines going up from your ISP to the globe dual stack. When we started, not many of them supported. They really asked, why do you need dual stack? Why do you need IPv6? It was an option. But now it is standard, right? ISP, my colleagues are there. So it is now standard. It's not anymore an option. And make sure that routing is efficient for IPv6, because IPv6 routes might be inefficiently advertised in some cases, so you have to be very careful in routing. And then you go into the business segments, say your VPNs, your lease lines, you have to then enable and give it to customers, right? If you want if you are on MPLS network, you can use these two technologies, 6PE or 6VPE technology, to enable dual stack on MPLS in an MPLS domain. And the nice thing about MPLS is you can only upgrade the edge and keep the core as it is. If you want, you can also translate it doesn't need to be a dual stack. It can be one stack, either IPv4 or IPv6. And then lease lines, and then you go on to VPNs. This is the customer segments. So 6P and 6P, I have a few slides. I don't think I have time to explain this, but these are on the internet, so you can go and check these technologies, how MPLS is using these technologies. It's not that difficult to understand. So 6VP, especially for when you are supporting VPNs on your MPLS network. When you are supporting VPNs on your MPLS network, you need 6VPE, where your MPLS labels are hang before the IP headers to differentiate the VPNs. So the biggest hurdle that comes to service provider is not the business lines, the lease lines, not the VPNs, but mostly the broadband. When it comes to LTE now, the new technologies, they by default come enabled for IPv6. But for a legacy kind of a network like a ADSL, it is coming from like 10 years back. Our CPs are sometimes IPv4 only. So we cannot upgrade that. We have to replace it. And some of our, say, BRSs may be not supporting, broadband aggregation routers may be not supporting IPv6. So we have to upgrade them. Or when we buy a new one, we have to enforce that it has to support the new protocol. And our counting mechanisms, your usage counting mechanisms, have to be able to count both protocols packets, right? So, and our DNS has to support when our people are on IPv6. If our DNS servers are not capable enough to handle those queries, then everything will fail. So our DNS has to support. And our billing systems, mediation systems, our operational support systems, configuration systems, everything has to support that. So finally, coming to custom equipment, the routers that we have here, and over the back there are LT CPs and ADSL CPs or fiber network CPs. They were not supporting few years back, but now they get shipped supporting dual stack. It's just a matter of ticking that dual stack enable V4, V6. When you tick that and then you do a simple tweaking on the router, it immediately starts giving you IPv6. But don't go home and do that immediately. We are now in the stage of deploying it, mass scale, but it will take some time. Gradually, we will, the new CPs are anyway shipping out to the customer enabled. And all the CPs, we need to do some changes on the field. And then the customer care. We have to make sure that our customer care people, our systems that support customer care, have to support, have to understand the two protocols and what the complexities are. Cost-wise, there's almost no cost. We didn't spend IPv6 specific dollars. I can make sure that I can actually commit to that because we didn't spend any money for IPv6 investments. What we did was we enforced policy, whatever you buy, next you have to have that capability. So there's no IPv6 particular investments. No added cost. In fact, to manage with the existing IPv4 traffic, we had to invest on carrier-grade netting. Because we didn't have enough IPs, we had to net maybe one IP shared with 32 customers, 64 customers or so. So for that, we had to invest. But for IPv6, we didn't have to invest specifically. Right? So all the things that we got was because we were ready and we learned the technology and we were ready and we started early. Training and development is the only cost I can tell you as a service provider that we had IPv6 specific. But again, that is also built into anyway the carrier level trainings that we had for engineers. That was inbuilt into that. So IPv6 just allows you to grow. It allows the growth to continue. It is not an expensive affair. For an ISP as big as us, there were no specific costs, but it takes time. Learn from the others' experiences. That is why LKNOG is there. Identify your unique strategy, how you go about it, doing it. I told you the steps that you need to take. And start early and gradually migrate into IPv6. Be a leader and don't get left behind. And LKNOG can assist you in the future. We hope to, Champika, I think we can arrange some awarenesses, workshops as if there's a demand. There are people that can help, and thank you. So Wi-Fi is enabled IPv6. You can play around and see what's happening there. You can see the prefixes. You can see how the DNS is working and everything is there. You can see what routes it's taking. And you check your laptop if you have one. If you have a phone, you can download an app and do this, see what's happening, and enjoy IPv6. Thank you very much.
Thanks, Asela. So do you have any questions for Asela? I'm sure you should. Anyone? Yes.
I think, Asela, if I heard you right, you said IPv6 would be available for ADSL customers soon?
Yeah, it is there. Now, our ADSL here is IPv6 enabled, but we are not promoting it in mass scale yet because there has to be some field configurations on the routers, existing routers, and we are planning for an automated configuration very soon, but not not at once, gradually. So we can experience what are any routing issues onto the internet and all that. So we will gradually do that.
If you are looking for beta testers, I am.
Yeah, of course, you can get. Speak to ISP. Indunil is there, DJM ISP, and he can definitely help you. There are several other guys from SLT. You have a chat with them, they will definitely help you. Now if you want to test, if you are an enthusiast, now you can get it. Now you can get it. Yeah. Can get it, right? Indranil.
Any other questions? Or any other
So
comments?
during the break, we can have a chat with the ISP guys. They will tell you how you can get it.
Yes, Pudu, you want to make a comment? Yes.
Before, Pubudu, what is the allocation that we get now if we ask for a fresh allocation IPv4?
/22 maximum.
Can't hear.
/22 maximum.
/22.
So
that is how many IPs?
1024.
1024 IPs.
Yeah, this is not a question, but I have a comment. So if you are interested about learning IPv6, we have in Epinic a quite informative web page. So if you can go to www.epinic.net/IPv6, and it tells you how to get IPv6 and how to deploy, and there are some case studies, just as Asela said, sharing others' knowledge. And it's very simple, so you can start from the beginning if you go to that web page.
Yeah, thanks, Pudu. Actually, no, it's very, very simple. I mean, it's just like it's a one click, right? Getting the IPv6 block is just a one click. Yeah. So, so with that, I think are there any other questions, feedback? Yes.
Yes, Asela, sorry. As you mentioned several years ago, we had this IPv6 working group or whatever it was called,
Yeah.
and then it died down. I think even at that point, it was not that the regulator was pushing it.
Yeah.
We
was
pushed
pushing.
it and then got the regulator also to say things that, I mean, we
They somehow
basically,
engaged at
yeah, I
least.
mean,
Yes.
we got them to have the meetings in that place and have the DG come and say some few words and go. We can do that again. What we need is, so this is again to the entire LKNOG, not entire, actually one of you, just one of you. If you would like to be Mr. IPv6 or Miss for that matter, and drive it, definitely LKNOG, ISOC, LK domain, and most likely Learn also would be very happy to support you to do that. But we need one volunteer to sit and do that, and that's a very good point on your CV. Just think about it, right? To say that you are driving the national IPv6 effort. So we can restart it. We just need one volunteer.
Yeah, thanks a lot, Professor Gian. One more, yes.
One way to push it forward, maybe now as a country, we are quite ahead in the software development. Now people have to move into the IoT side. But one inhibiting factor is that IPv6 is not made available publicly, or people are not using it publicly. So I think a lot of IoT development will take place if this is pushed forward. So even to get the regulator motivated, this can be put forward as a kind of a reason why it should be enforced.
I'm not hearing it properly. Maybe there's a bouncing effect.
He's not hearing your question properly.
Yeah, in fact, it's not a question. What I said is one way to push forward the regulator is that we know that Sri Lanka is well ahead in the software industry, but we have to move into the IoT side. We are, I think, still sort of not there yet. But one inhibiting factor is that IPv6 is not kind of very much used, which is essential for IoT kind of environment. So we can probably use this also as a kind of a motivation factor to get the regulator to enforce it.
Yeah, I agree with that, and yes, definitely IoT is a use case.
If most of the industry get together and say, yes, we want you to put a regulation like this, they will put a regulation like that. I mean, they are very happy to do whatever the industry asks them to do in these technical parts. So only thing is, it's very difficult to tell them to do things on their own unless if they feel the industry will resist it, because that's just bad for them. So I think we as the industry have to get ready, have this famous meeting, come up with a thing, and then forward it to the regulator as a industry request, and then they will basically send it back as a circular.
So now, this is, since many of you have not brought your laptops, this is the demonstration. Can you see those numbers? So this is the, now if you type DNS lookup on your command line on a Windows machine, then you see the resolving address, the DNS server is a v6 address. And if you say slt dot, www.slt.lk, now you get the resolution for both IPv4 and IPv6, right? The top one is IPv6, 2402 D000 100:2:2. And that is the IP that is preferred by Windows 10. My machine is Windows 10. Windows 8 is as well same, Windows 7 is same. And if you do a trace route, trace route to www.slt.lk or google.com.lk, you will see your route going on to the IPv6 internet. So that's what I need to show you. The world is now real. It is no more a minority, and it is soon in Sri Lanka also. Dialog is providing already on LTE. We are providing, and it will soon go to the mass market, and our traffic will be like swelling like hell, right? So we can exceed India 50% soon.
Okay, I think given the time limit we have, I think probably, I'm sure that you have a lot of questions, but you can talk to Asel offline, and also, do keep in touch. We hope to have some mailing list as well created afterwards, so do have these discussions. In the future, we also want to do some more hands-on workshops as well. So these are some things that we are planning. So with that, thanks very much, Asela, for your contribution, and just give him a big hand. So the next speaker we have is Tilina, and Tilina Pathirana. Tilina, he's from Learn. Previously, he was the network manager at University of California, and now he's with Learn. So he's going to talk about network monitoring and measurements side of it. So, he'll of course focus on the V4 as well, and so he'll generally talk about the network side of it. So, thank you.
Okay, good morning. I think it's still good morning. Oh no, 12:30. Anyway, I'm going to do something. I'm going to show you some quick overview on what we do in Learn on the terms of network monitoring and measurements. So what is monitoring? Everyone knows what is monitoring. Just we want to check what is the status of our network. So it's simply that is it. So what to monitor? Infrastructure and the services. I am not going to go into deep because of the time. And why to monitor? Check your reachability, availability, utilization, performances, and then identify faults and outages. That will be our main things we will monitor. Again, what to measure? Why measuring? Why do we need measuring? Identifying what type of traffic or what content of things going on our network. Can be many things. It can be a possible attack. If you can see high traffic, unusual traffic, then it can be a possible attack. Again, it can be billing, and then troubleshooting. And there are many more things. So what to measure? Latencies, paths, bandwidths, losses, lot of things. Even traffic monitoring. By traffic monitoring, we can do lot of measurements. And how to measure? Active measurements, passive measurements. What are those? Active means tapping something actively and or flooding the network and do the measurements. Passive, it's kind of what we do in SNMP. I know everyone knows SNMP. And our sponsors, Paracum, they are doing, I think, kind of active, passive both. Please correct me if I'm wrong. So, some tools we are using in Learn, basically most of them are in open source level. So, Cacti Nagios, I know everyone knows that. LibreNMS, kind of an open source altogether package, LibreNMS. And for NetFlow analysis, NFSense, Nmon, HTOP, Munin, those three are for monitoring servers, server sites, server utilizations, those things. So for measuring, we can use smoke ping. I guess everyone knows smoke ping, and Persona, a framework which used for doing measurements. iPerf, most of us use iPerf, BWCTL, bandwidth controlling, and another term, repeatless. I will come to that in the later part. So for monitoring, these are example. I will go through some example images, screenshots, and most of them are publicly available in our website, www.learn.ac.lk. Anyone can go there and access it and check what is the current measurements or what is going on at the moment. So this image was taken yesterday around 1 p.m. You can see University of Peradeniya, Moratuwa, Kaladi and Srijawardhanapura in one image. So this is a Cacti-based monitoring one, and we have given it several colors depending on the bandwidth utilization. The green one is their downloads, and the yellow one is the upload. But the orange one is their excess use. So if one of our customers having a bandwidth of 100 M, and if they go beyond 75% of that, then the graph will be orange. Likewise. Again, this is another Cacti example. This is the monitoring part of individual hosts. It can be servers, it can be routers, it can be anything in your network. So you can see some red color icons which are at that moment which is on down state. So this shows what is up and what is not. Again, a Cacti monitoring graph, one for traffic utilization and the other for ping latencies. You can see some ping differences when the traffic goes up. Again, this we call this weather map. This is again an SNMP based Cacti version. This is actually the whole Learn network at a single instance. So you will see a lot of Learn institutes which is connected to SLT VPLS, and it will show you in different colors how their utilization is, and even the internet connectivity is. Okay, so for measurements, this is an example of smoke ping, which was taken around 9:20 to 12 a.m. Time. So you will see a lot of smoke because of the high usage at that time. And if you go for the down image, you will see a lot of black parts in the end of the graph because of the high bandwidth usage. You cannot simply say what this is, but as a person who every day looks at it, I know, okay, what this is. Again, Learn hosts bandwidth monitoring tools in our website. Anyone can access it and check what internet speed you get. So the server is in Colombo, and you will be checked in Sri Lankan servers. You don't have to go to US or somewhere else to check your speed. So if basically it's hosted in within Learn, so your all traffic will be routed through that. So this was taken yesterday from my laptop, and you can see the speeds. And the next one, as we were talking about IPv6, this is one of the screenshots I took when I was working for University of California. So what we did there was we hosted a IPv6 test node, and this is one of the screenshots. I have masked the IP addresses, but you will see that it will test IPv4 and v6 connectivity and the speed. So if you go to www.ipv6-test.com, there will be several test nodes. One of it is University of California node. So I think it is the only one in the Asia Pacific region. So if you go to China and check, it will be the California testing point. And the graph shown here is the IPv4 and v6 traffic based on net flow data. As Asela said, IPv6 enabled institutes within Learn are having more than 50% of their traffic going through the IPv6, because most of our people use only Google and Facebook as the internet, not the actual internet. So Google, Facebook, they support IPv6, and because of that, most of the traffic goes through IPv6. So if your network is on IPv6, you can check it, you can monitor it using NetFlow-based analysis. So again, a NetFlow-based, I'm not sure you can identify the numbers. Here, these are the IP addresses which was taken for a period of 30 days. And these are the top IP addresses which were counted. The first 5 IP addresses are IPv4 addresses, and the other 3 is IPv6. But the funniest part is, out of that all IP addresses, except for 2, all other goes to YouTube. So if you count the total, it's around 10 terabytes of traffic going through IPv6 only for YouTube within 30 days. So the next figure, it's the IPv6 usage of that same period. Again, the first 3 goes for YouTube, then again Facebook and Akamai. So our people use a lot of Facebook and Google, YouTube. Actually, not Google, YouTube. Again, Perfsona. Perfsona is a toolkit to use for bandwidth measurements, latency measurements, and many more other things. Currently, we are hosting 2 Perfsona nodes in Sri Lanka, one within Learn and the other one in University of California. So this screenshot is from the Learn node, and anyone can log into that and use it for your purposes. You can check your network connectivity and everything. And this is a throughput test within learn node and a node in NSRC. So you will see around 45 M traffic every day. It's checking the bandwidth. So if we are seeing something unusual, then definitely there's something going wrong. Maybe a breakdown, maybe some issue, or anything. So we can do this monitoring and do this continuously and check whether there is any issue in our network. So who knows what this is? Okay. Seems like most of you doesn't identify this one. This is the Atlas test page, publicly available data. These are the only available test nodes in Sri Lanka at the moment. One in Airtel, Learn, Eastern University, Open University, University of Visual and Performing Arts, University of Moratuwa, Kalaniya, Lankacom, Etisalat, and another unknown two. I'm not sure what these two are. So there are 11 RIP Atlas nodes at the moment in Sri Lanka that is working, and there were 40 in the list. So 39 isn't working at the moment. Anyway, this image, the map, shows a test between Learn node and the some other nodes around the world for reachability. So at that time of testing, you can see there are a lot of nodes. Actually, it's 50 nodes, and some of them are in black color, which is not reachable. So with that test, we can identify from our network where we can't access. And if you host several nodes within your network, you can identify your own problems in your network. I think our friend from Punic can also do some commenting on RIP Atlas, because they are also promoting that. Anyway, sorry, I just rushed through a lot of images, and if you need any measurement regarding things to know, just you can ask me anytime, and we are hoping in another future LKNOG to do a network monitoring and management and measuring workshop. So, any questions?
Any questions for Tilina? Yes, Asel.
All these tools are open source, and you have not paid anything for it, right?
Sorry,
all these applications are open source.
Yes,
and
open source.
It's not under support from anybody.
No, most of them are under support, because there are a lot of issues with open source. So we have to know what we are doing exactly, and yes, there are a lot of commercial variants of those softwares. But
what differences do you see now? What challenges do you see using open source? For example, if you are like corporate network or a service provider, what challenges do you envisage?
First challenge what we are facing is if something goes wrong with the tools, or if there is a kernel update, because most of them are Linux based. So if there's a kernel update, if there's a software major updates, it may not support our existing system. So then we have to know thoroughly of what we are doing. So we have to be very up to date. That is one challenge. We have to be knowledgeable. and that should be in our source, otherwise no one will use it.
Yeah, but the kernel upgrade is also a choice, right? You can just avoid it if necessary.
Sorry, I
you
didn't.
can, it's an option, right? Kernel upgrade.
Yeah,
You can take the option.
Yeah, best thing is to
Test.
Best thing is to do the update, because otherwise there will be a lot of security issues and lot of issues with the distributions. So do the updates, but at the same time you have to be know what you are doing. It will definitely be a problem if you are running Nagios and Cacti. It's a big headache when you are going to do an upgrade. Better to go for commercial products if you have that capacity. And I'm not saying everyone can do that. Open source, it's free, so you can use.
Any other questions for Tirina? Okay. If not, yeah, thanks very much, Tirina, and please give him a big applause as well. Okay, actually, next is, I'm in line next. So I will cover the ICANN update presentation. And then, actually, my presentation has got, in fact, two components. One is covered by Harsha. So Harsha is already here. So I will cover parts of it, and then I'll hand over to Harsha for some discussions on a certain topic. Okay, I need to get my slides. On full screen here. Oh. Okay, while Asela is fixing that, I will talk the essence of what I wanted to talk. So basically, to give an update about ICANN. So in case if anyone is new to ICANN, I'm sure that number of people may have heard about ICANN before. It's a very long acronym. It's Internet Corporation for Assigned Names and Numbers. So ICANN is a multi-stakeholder body, a non-profit multi-stakeholder body, and a global body as well. The main objective, of course, for us is to coordinate the internet identifiers. So when I say internet identifiers, as you all know, any device that gets connected to the internet needs to get a certain identifier. So these identifiers are things like IP addresses, things like domain names, protocol parameters, like for example port numbers and so on. So ICANN coordinates these identifiers and make sure these identifiers are unique. So we ensure the uniqueness of these identifiers. I think it's gone back again. Okay. All right. So I have put here like three things. Of course, one thing is the protocol parameters. As I said before, things like port numbers and so on. And then the names are pretty much domain names, and then the IP addresses, of course. Now, we had some discussion before about IPv4 and IPv6. So in terms of IPv6, Our role is that we have a function called IANA function. IANA stands for Internet Assigned Numbers Authority, and currently it's called as the PTI, Public Technical Identifiers. So IANA keep the central pool of IP addresses, or PTI keep the central pool of IP addresses, and then delegate or distribute to the regional internet registries, or RIR. So in Asia Pacific region, of course, it's APNIC that distribute the IP addresses in the Asia Pacific region, and also engage with the community, especially with the policies and so on, right? Okay, so DNS is also something very important for us because we coordinate the domain name system, or the DNS. Now, as you all know, DNS is a distributed database, right? You can see here we have root in the top of the DNS hierarchy, the root itself, the root database, or we call root zone. And then we have lots of these delegations, or top-level domain delegations, TLDs. So when you talk about TLDs, or top-level domains, we have things like, of course, generic top-level domains, things like .coms, .nets, and so on. Then we have country code top-level domains. And also, actually, in the very recent times, we also have started having, since 2012, the new generic top-level domains, things like .anything. So nowadays, you'll have companies, nowadays you have even cities like .Tokyo, or professions like .lawyer or .engineer, things like these exist. So these are new generic top-level domains. And also we have these IDNs. So if you see the top-level domain range, so there is IDN, or internationalized domain names. So this is where actually we want to have some, generate some discussion as well, which Harsha will do that discussion. So, and then of course we have our second level domains and so on. So if you are a corporate, if you are enterprise, if you are a ISP and so on, you could be having your own second level domain that you manage. So these are all delegations all the way from the root to top level domains and to the next level and so on, right? Okay, coming back to internationalized domain names. So just to give a very quick brief, currently, when we type domain names, we type in, say, in English or Latin characters, basically. But we should be able to write domain names in local scripts, local languages. So currently, there are many scripts have been delegated to many countries and so on. So even in Sri Lanka, there are 2 scripts that have been delegated as well, .lanka in Sinhala and .ilange in Tamil as well. Also, another development which is happening is obviously to have these different labels in the root itself. So, for example, if maybe in the future, if someone want to request for a TLD in a very specific string, that should also be delegated. So these are the development work that we need to actually do to make sure those rules and labels are well defined. Right? So that's where actually Harsha will talk specifically from the language generation from local context. So currently over 1,200 or so generic top-level domains have been delegated, especially including the new GTLDs and so on. So I won't go too much details into that. See, there are some statistics. One of the challenges, in fact, actually, especially if there are some people who are working on development work, software developers and so on, this is where something that you can still be involved, not only software developers, of course, it can be, any of you can be, can participate in this. So this is what we call universal acceptance. So what is universal acceptance? Say, for example, I was talking about IDNs before. If you say, type a domain name in a certain script, or if you type a domain name that has got a new generic top-level domain, say .city or .kitchen or something like that, will the applications or the search engines or the email clients, things like that, will they really understand this? Right? Or will there be some filtering process? Or will they not handle it properly? Will they process it properly? So these are all things that we will have to handle. So this is where the universal acceptance will come into the picture. So currently, there's a whole lot of community members. There's a working group that works on this. You can join this working group, and that's called universal. It's actually a steering group. It's called Universal Acceptance Steering Group. And you can contribute to that as well. So that's something that just need to be be aware on that. One thing also actually wanted to highlight, that's about the root servers. Earlier I was talking about from DNS perspective, top of the DNS hierarchy, that's the root. So basically we have a root database or a root zone. Now the root zone has to be of course kept quite securely and make sure that the root is secure, stable and resilient. Right? Because there can be lots of DDoS attacks coming into the root and so on. So that's why we have to make sure the root is stable, root is secure. So we have these root servers. Basically the database, the root database is kept in root servers, and there are many root servers scattered around the world. So there are a number of root server operators who operate these root servers, and also they are all scattered around the world. Now, if you take ICANN is also one of the root server operators, and there is a certain naming convention for these root servers as well, starting from letter A to letter L and letter M. And ICANN operates the L root server. So in case, say for example, if you are operator, if you want to have a root server in your network, you can actually not talk to the, you can talk to ICANN, of course, if it is a L root, but also there are other root server operators who also can work with you and put one of their root server operators in your networks as well. So there's always possibility that you can do that. So, and also having a root server in your network will give a lot of benefits. Of course, the DNS response time, right? We'll get a much better response time. I remember even when I used to work with APNIC, we worked with, say for example, with SLT, and we put a root server in SLT network as well, right? So in the same way, so there are some operators in the recent times who have put some root servers in their networks as well, even ICANN L root servers. So do talk to us in case if you're interested in having any root servers in your networks. This is just how a simple DNS query gets resolved. You probably all know that because you manage the networks and well. So this type of DNS query, of course, will go to a resolver or a recursive server. Now, these recursive servers are managed by the operators like yourself, right? So you manage the DNS recursive servers for your clients, for your users. And then these queries will be then sent to root servers, and root servers will give, as we discussed before, DNS is a hierarchical database, so root server will respond with the next TLD zone, the name servers, and then the TLD server will respond with the next level, and so on, and finally, the recursive name server will get the answer and return that to the client. So client gets the IP address basically for the web server they are looking for, and then the client can go and visit that website or the web server, right? And download the web page. So this is how a simple DNS query gets resolved. Now, one of the things what I want to highlight here is that these sort of DNS queries can always can be abused, for example. We can't say they are really secure. Sometimes nowadays we have lots of these DNS hijackings happen. Nowadays we have these DNS cache poisonings happen, because if someone managed to poison the memory or the cache of the recursive name server, then obviously the recursive name server will give wrong answers to the clients. So this is where lots of these phishing attacks and things like that can happen, especially lots of banking websites and so on are being phished, and so many of these issues come because of this cache poisoning issues, DNS hijacking, cache poisoning, and so on. So protecting DNS infrastructure is very important. Now, there are various security mechanisms in terms of protecting DNS infrastructures, but one of the important security mechanisms is something called DNS Sec, or DNS security extensions. Now, DNS security extension or DNS Sec is quite important because it can protect your DNS data, right? So for example, cache poisoning type, DNS hijacking type, these kind of things can be protected using DNS Sec. So in case if you have not deployed DNS Sec, probably you should think about it, right? So you can, what we do is basically we sign our DNS data basically, right? We digitally sign our DNS data, and then those signatures can be validated based on the public keys. So that's the basic theory behind that. And so what you do is, in case if you are managing your DNS databases, your authoritative servers, you can sign your authoritative zones. And then if you are running validators, say for example, if you are the operators, if you are ISPs and so on, if you are running recursive servers, the resolvers, what you can do is you can always do the validations. So there are two aspects in DNSSEC. One is the validation aspect, and one is the signing aspect. So be aware of this security mechanism. I'm trying to actually go a little bit faster given the time limit we have. Some very quick stats on DNSSEC deployment. If you see the world map here, all the green areas, so these are all country code top-level domains like CCTLDs. All the green areas, that's where all the CCTLDs, they have signed their CCTLD zone. Say, for example, if you take Sri Lanka, .lk is the CCTLD zone managed by LK Registry. In fact, LK Registry implemented DNSSEC very long time ago as well, right? So you can see it's all in green color. But there are some countries, of course, in some of the white areas there you can see. Those CCTLDs, they still have to deploy DNSSEC. Now, if you see those red color bars in your left side, those stats are based on the TLD. So the leftmost column, that's the percentage of TLDs like .coms, .nets, and so on, who has signed DNSSEC or who has deployed DNSSEC. So you can see currently in the world, about 90% of the TLDs, they have deployed DNSSEC. Now, ICANN also has got contracts with like registries and registrars, especially the GTLDs, the new GTLDs, and so on. In the new registry contracts, it is necessary that you have to actually deploy DNSSEC. That's why we see there's a lot of DNSSEC deployments at TLD level now. Now, if you see the middle bar, the red color portion is very, very limited, very small. That is because these are the second levels. So after the TLDs, then you have, say, something.com, right? So if you have not deployed DNSSEC in your own zone, that means you are in that white space. So you can see that 3% is like that red area is only like 3%. So that 3% is very, very small actually currently. So we have to actually get that improved, right? So if you sign your zones, if you sign your corporate domains and so on, we can then make sure that that figure gets up, right? And then the last one, the third bar, shows the validation, DNSSEC validation. So if you are an operator, if you can validate your client queries coming in using DNSSEC, then you can see currently in the world, there are like 16% of the, around that, 16% of the DNS queries are DNSSEC validated. So this is something that, which is currently happening as of now. Now, one very quick update. Now, when you start signing your zones, of course, you'll have to use these keys. These are called, you have key pairs, basically. You have private keys, and then you have public keys. Now, private keys, of course, you keep it safe, but public keys you publish. And then signatures also you publish once you sign your DNS data. And then the recursive servers, the resolvers that you operate, the network operators that you operate, if you have deployed DNSSEC, those servers will go and validate these, right? Validate these signatures. Now, in the DNS hierarchy, we have different levels. So we have second levels, we have top levels, and then we have the root. So root also has got the keys. So root zone is managed by the process that ICANN and IANA coordinates. So in the recent times, actually, if you talk about the root keys were generated about 6 years ago, 7 years ago, back in 2010. So that's when the root keys were generated. So currently, the root keys what we have They were generated about 7 years ago. But there's no problem. We can still use the same root keys. But the thing is that it may not be very good if we have to continue with the same root keys for many, many years. So it's a good practice for us to change the root keys, just like changing your passwords, right? So ICANN has started this process to change the root keys. This is what we call key rollover, right? So KSK stands for key signing key. That's one of the public keys that that we have in the zone, right? There are different type of keys as well. KSK means the key signing key. So so this key, the root key, is going to be changed now after 2010. So this is going to be changed. In fact, actually, it was scheduled to change 11th of October, in fact, this month. But it didn't, it was postponed because many of the operators who has deployed DNS Sec, they are validators, they have not updated the root keys in their servers. So that is why actually the process has been postponed for a while. In fact, there'll be more updates coming up about this. So the message what I want to say, especially for operators, is that you have to make sure that you update your check whether if you have deployed DNS Sec, of course, whether you are using any resolvers who has got deployed DNS Sec, and also make sure that you are using the new root keys that have been generated in last year, basically, because we generated these root keys in 2016 October, right? So just make sure as the operators these updates have been happened. In case if not, we have put a lot of information, a lot of resources in ICANN website as well if you go to our website. So just be aware, because this is a very specific thing for network operators here. So basically, you can get engaged with ICANN in many ways. Just to summarize, there are lots of policy discussions happen as well that can relevant to you yourself, your operations, your businesses, and so on. ICANN has got 3 public meetings every year. You can either physically attend those meetings or you can participate remotely as well. There are lots of fellowship opportunities as well where you can apply and physically attend these meetings. So main thing is try to be engaged and contribute to this process. I think with this, I can take any quick questions if you have. Otherwise, I'll hand over to Harsha to focus on the IDN stuff, from a local perspective. Are there any questions? I know it was quite fast, but.
How, like say now, for me, I don't have a acrylic keyboard or a Chinese keyboard. So if I want to communicate with you and your email address or your domain is in Chinese, how does that mechanism work?
Okay, I think probably Harsha might go into a bit detail. The main concept is, see, like when we type, as I said, like, it's all ASCII, right? So DNS also understands the things in ASCII. So when you type a domain name, DNS will understand in ASCII. But of course, when you write a local script, say in Sinhala language or in Tamil language and so on. So if you type a local script, there's a Unicode behind that, right? So we have to make sure that ASCII has to be converted to that Unicode. So there is a conversion code as well, and this code is actually called Punic Code. So, and also the other thing is that we have to generate the proper labels to make sure that this conversion, these labels are correct and it's valid. So this is where the label generations will come into the picture, right? And then, so talking about the DNS resolution perspective, there is a certain Punic code, right? Say, for example, every IDN will start with, say, ASCII XN-, and then there is a certain code for that. So based on that, DNS knows exactly what is this string, right? So that's how it's get resolved through DNS. Right? But the whole generation process is different. So that is up to the local expertise who knows about the language to define what are the strings should be and what are the rules of the language should be and so on. So that's something that we have to do within, as a community, we have to work on those rules, right? Yeah. Any other questions? Yeah.
if you are not hosting the DNS locally, but hosting in a, there are many DNS hosting companies in the cloud. So can we enable DNS Sec in those hosted?
Yeah. Okay, so first of all, when I talk about DNS Sec, I told you there are two aspects. One is the validation, and the other one is the signing, right? So if you are hosting, say, your domain name in somewhere, so you have to make sure like who provide the authority for that DNS, who are providing the authoritative servers, right? So then obviously they will have to do that signing process. Right? So you have to make sure that they are capable of doing that signing process. So if I take, say, from a simple domain, say if it is something .lk, right? If it is something .lk, then obviously your DNS, your parent would be .lk. So you have to make sure that .lk has signed. Otherwise, because in DNS Sec, your trust would always propagate all the way to the root. So for example, if you sign yourself, say mydomain.lk, if I sign that, I have to propagate that trust to my parent first. So which means my parent should be able to know that the child has secured itself. So basically, parents should be getting a hash or the hash of the child's public key to the parent zone, and then they have to put that hash into their zone and then re-sign it, and then send the hash of the parent to the root. So that's how all the way this trust get propagated. So let's say your parent has not signed deploy DNS Sec, then you're kind of stuck, right? Because even though you have signed, you can't propagate the trust to your parent. So you have to make sure that when you're hosting with someone, they can support these things. First of all, the validation. Of course, validation will come in case if you're using their servers, their DNS servers for resolution. You could be using Google, or you could be using your local ISP and so on. If depending on whom you're using, and if they can do that validation, that's fine. But in the case of signing, you have to make sure that whoever that DNS name servers, authoritative servers, can support the signing part of it, right? So I hope the two aspects are clear. Any other questions?
Yeah, I want to answer the question. Now that the Learn has one of root server hosted at the Learns, and we were told that it's up and running. So my question is, what it really means to the partnering organization in terms of resolutions, and what are the benefits of having a root server, particularly for the Learn network?
Okay, yes. So yes, you're right. So in fact, actually in the recent times, we had one of the root server host here in Sri Lanka as well, Learn. So they have, you have a root server in your network, which is, so that means, say for example, when a DNS query comes in, now if you talk about, say, LRoot, right? So LRoot has got about 160 instances around the world, right? So some LRoots could be in, say, in India, or some could be in US, some could be in the Europe, and so on, right? Say if you do not have a root server here in Sri Lanka, obviously, when if you remember that DNS query process I had, first the recursive server will go and talk to root servers. So if you don't have a root server locally, your query will go outside. Maybe it depends on, of course, the routing and how your upstreams are connected and so on. But most likely, your query will go to outside world and then has to come back, right? So this means there is a time or there's a certain latency over there. But if you already have a root server in your network, that response time is very quick. So that's why actually you'll get a much better, faster response time. And that will improve the performance or the DNS performance to your clients as well. In the same place, say for example, in your data center, if you can put both root server and a TLD server as well, then it's even much better, right? So that's how it will benefit your community, your users, and so on. Any other questions?
I have a question about now the resolvers. What do they need to, now for example, the service providers, they have to have their resolvers for the users, right? So for DNS Sec to be deployed, what do they need to do?
Okay, so if you're talking from a resolver's perspective, I think, I don't know, I don't have the slide now, the video is running, but if you remember that slide I had, the client talks to a resolver first, and this resolver is generally run by, say, ISP operator, right? And then resolver goes and talk to root, and then root would say go and talk to authoritative of TLD, and then TLD would say go and talk to the authoritative of the next level, right? So ultimately, the resolvers, they are going and talking to the authoritative servers. So if you have, say, SLT.lk, SLT.lk has got your own authoritative servers serving the SLT.lk zone, right? And then you might be also having your own resolvers for your clients. So your clients could be visiting either your website, or your clients could be visiting maybe outside world, other websites and so on. So in terms of resolution, what you're doing is you are helping your clients to go and, when they visit outside, other websites, you are giving them a validation. In case if they have signed their website, you are giving a validation that this is the correct place. Because in DNS Sec, what you are trying to achieve is authenticity and the integrity. So if I'm going to a certain website, I know that I'm really going there. I'm not going to a phishing site. I'm not going to a site that looks like your bank website. I'm really going to the correct website. So the authenticity factor and the integrity. So as a resolver, when you, in terms of signing and the validation can be done first, because you don't have to do all the signing, you don't have to get into all the other overheads like initially, right? Like managing keys and things like that come later on. But if you are doing the validation part, you have to make sure that when you get queries, right, first of all, when you talk to root servers, when you go and talk to TLD servers, when they respond you with DNSSEC enable response, you are capable of validating those responses. That's what you have to do, right?
So if the DNS resolver is not capable of handling DNSSEC, what happens?
Okay, if it is not capable, say for example, if I am a resolver, right? If I am a resolver, say I am the SLT resolver, right? And you are, say you are the client. When you come and talk to me saying, okay, I want to go to www.mybank.com, right? And say I can't do that, right? So for example, if I understand now, from a resolver's point of view, I can be configured with DNSSEC, right? Or I may not be configured with DNSSEC. So there are two options, right? Either I understand DNSSEC or I don't know DNSSEC. If I don't know DNSSEC, no problem, right? Because I will behave normally. But still work, of course. I will work because I don't understand DNSSEC. But if I understand DNSSEC, right? If I understand DNSSEC, and in case if the signatures are not validated, say mybank.com has not signed their zone. So if the signatures are expired, when I try to validate, I say, oh, okay, I can't validate it because for some reason I can't validate because their signatures are not correct. So then I will not give you the response, right? So you will not be able to go and visit the bank website. So that would be the end result. So basically server not found. So you won't be able to get there, right? Any other questions? Okay, I think with the amount of time we have, if you have any questions, feel free to have some discussion over the breaks as well. I'll hand over to Harsha, who will have the discussion on the IDN side of it.
Well, I'm sorry that I don't have the slides I did prepare because there are so many things happening while I'm speaking right now. So one of the things actually I want to discuss about the IDNs and where I think the LK domain registry had done a lot of work previously. You know that .lanka and .ilange had come. I think it was one of the I think even before India, we had actually had the Ilange. There are 20 scripts that they have the official language, but before of all those scripts, that we had the .lanka and .ilange. I remember very interesting. I remember that when it was inaugurated, and they couldn't show on Mac the .ilange and .lanka at that time, right? .lanka was not there, I think. So anyway, now what's happening? LK domain had given the second level, the rules had been done, and so the University of Colombo School of Computing, LTRL, also had done the rules. There was a question came about the inputting, I think. So the address bar, you can input it. Now if you look at it, you can see Sinhala. Some of the websites actually with a slash, you can see the Sinhala. You can input Sinhala right now because it accepts. But actually what is happening is, when you put the Sinhala, it converts into what you call the Punic Code. So what you have is the Punic Code actually. So now there are certain issues that the Punic Code also has for the Sinhala. In 2007 version, there was an issue of Rakaranse and Yanse. You know how the Rakaranse in Unicode, what we have is a zero-with joiner. There is something called control characters, zero-with joiner. That was not accepted because there's a security reasons they had not allowed. And Yanse also had the same issue. So the Halkirima Yan is the Yanse, Halkirima Rayan is the Rakar. So these two forms, and there were some other things like numerals, for instance. How many of you know that Sinhala has numerals? Can I have the hands up at least? Right? So this numeration now is not allowed in the domain names, and there's a cross-scripting like different scripts. So these, basically, there were rules, and which, yesterday also I was having a discussion with Professor Gihan, and he was telling me that he had done some of the rules earlier. So now the idea is, what we are going to do is, we are going to have the single generation panel, these labels, and also to come up with rules. Now, as I pointed out, the Rakar and Yanse are very important. After 2007, there were a lot of discussions on this. And so they said they are going to allow Rakar and Yanse, but still not properly done. So the rules have to come. So there are so many issues that we have to discuss also. So we basically, the UCSC came up with, there was a research that they had done for the LTRL. That's a local language research, the technology group, the lab. They have done, and there was also the paper came about how to actually come up with the secondary level name, the level, and also like some of we looked at Telugu, we have looked at Malayalam, because if you look at the Malayalam Ka and the Telugu is a very nicely round letters, so so that can actually get mistaken for Sinhala even. Right? All these rules actually we had been looking at, so now we have to bring all them together in the region. So what we are going to do, we are going to have that single generation panel, and so Dr. Sarma, then Champik is also involved. So we are going to have it in Sri Lanka, so we are going to form that. So we have now already, we have asked certain members to be part of that. Now, one of the things I think I take this opportunity right now, I think Champika, I think we have to actually emphasize on that. We would also like to have some members from the ISPs, Internet Service Providers. So if you can actually, so the last time when we had the pre-group meeting, we were discussing about having some members from the ISPs, Internet Service Providers. And so if you can name some, I think we will formally invite, we'll send you the letters, and that we will have, and ISOC will already be part of that. And also there are other members also, we have a particular group. So we are going to form about 20 members, roughly, but we need only about 10, but we can fall back. So there will be like, there are different members will be in different groups in this group. So anyway, in December, second week of December, we are planning a conference, and so that the Indian, that's called Neo-Brahmi. Brahmi is the original language that all of these scripts had actually evolved from. So they are going to meet in Sri Lanka. So we are going to have a training sessions, and we are going to open it to public, and some of you also can actually, in fact, today I had a meeting in the morning with Dr. Sarmat. What he told me was that actually we are going to open it up to about 40 members from the government and the semi-government, plus in addition to that the ISVs. So that will happen. We'll actually announce that, that particular, how it's going to happen. And also there will be a training sessions on this. And then this generation panel will be in there. And another very important thing about this generation panel is the Tamil. Now the Tamil, of course, there is a very interesting, because the Tamil we don't have to worry about actually, but still we have a certain interest in Tamil, right? Because the Tamil is one of the official languages of Sri Lanka, and also it's a very important for us also. So therefore, some of our members that we are going to have permanent members in our group also, who will be contributing to this the formulation. So so the idea of having the generation panel is to bring the kind of togetherness in the group and to discuss about the rules, and also to learn from them, and also for us to formulate the rules as well. So anyway, these rules have been done earlier, and we are also going to look at that, and we are going to add whatever that is in there, and to work on it to make it for the future. So at the moment, .lanka and .ilange, that the LK domain is actually giving basically free for anybody to, if you purchase a LK domain. But in addition to that, also in the future, there will be a top-level domains that are like .anything that can come forth, and these rules are for that as well. Anyway, any questions? So I actually did it in 10 minutes, so that any questions that you have on this, and I'm happy to answer. Anything on anybody who likes to be part of this? Can I have the hands up? No one wants to be part of it. I think Rajiv is already there. Anybody who likes to have? Anyway, we'll have a.
Thank you, sir. Actually, before we wind up the morning session, we have some giveaway tokens to the speakers. So to give away the tokens, I would like to call Dr. Roshan Ragel, CEO Learn, to give away the plaques. Yeah. First, I would like to invite the first speech, Asela Galapati from Sri Lanka Telecom. Then I would like to invite Tilina Patirana from Learn to be on stage. And Harsha Vidyavardan, sir, to be on stage to accept it. And I would like to invite Champika Vijayatunga, one of the key person to organizing this event, to be on stage. Thank you, Dr. Roshan. So we'll stop the morning session for lunch. So we'll try to start at 2 p.m. For the panel discussion. Thank you. Enjoy your lunch.